Hey, welcome to 8.4 part, is it 8.4? Yes, 8.4 day 2. Alright, welcome. To start off with, we are going to review what we learned in 8.4 day 1. So actually, if you even have that note sheet out, it would be really handy for you to just grab it. I just want to go run through what you learned yesterday. So I'm going to do it fast, look back if needed. First, common log. Remember, if it just says log, really, it's base 10. So feel free to add in the base 10. Natural log. If it looks like ln, really, it's log base e. Or you could say ln base e. Either one is fine. So fill that in if needed. Next, property. If I have anything, any base, and I have a 1 right here, the answer is 0. Next property I want to review. Let's say I had this, log base 6 of 6. Whenever these two numbers are the same, the answer is 1. Next property, let's say I had 4 to the log base 4 of 6 power. Remember I said that these cancel each other, so that answer is just 6. And we're going to talk more about that one today, which is going to be nice. Here's another one. I had log base 5 of 5 to the 2x, for example. If these are the same, then that whole thing cancels and just the exponent is the answer. And just a quick review. When I'm doing logs, let's say I said evaluate, set it equal to x, change it to exponential form, and then you do some guess and check action to figure out what the answer is. And I hope that we'll have time to work on that a lot, because that takes a while to get the hang of. To start off with today, for our new material, we're actually going to first review how to find inverses from Chapter 7. So we did this in Chapter 7. Let's just review and see if you remember. So from Chapter 7, if I'm going to find an inverse, remember, step 1, switch x and y. Step 2, solve for y. That's what we did in brief, as a brief explanation. So here I go. Step 1, switch x and y. Step 2, solve for y. X plus 3 equals 3y, divide by 3, divide by 3. Just don't forget to put the divide by 3 to both parts. So I end up with, either you could say x plus 3 over 3 like that, or I could split it up into x plus 3 and 3 over 3, which is 1. Why don't you pause it and try B and C and see what you remember from Chapter 7. Alright, you have unpaused. Here's our answers. And at this point, that part was review, so if you didn't remember how to do any of those, write that down, but you can ask me questions on that tomorrow. So we're not going to use the fifth written stuff in our today's lesson, because we're going to be using logs and e's. Just the main process of switching and solving is what I'm looking for. Okay, to find the inverse of a logarithmic function, the first thing you should know is that the inverse will be exponential. So the thing that we're going to talk about for the rest of this chapter is that logs and exponents undo each other. It's kind of like how if I had x squared, a square root undoes the squaring. If I have something logged of something, if I do an exponent, it undoes the log. And I'm going to say more about that in a little bit, but logs and exponents undo each other. They're inverses. And we actually solved this the same way we solved those warm-up problems we just tried, which is switch x and y, then solve for y. It usually takes students several of these to get the hang of it, but if you feel like you got it, go ahead and fast forward and then check your answers. I'm going to first switch x and y for part A, so I got x equals log base 3 of y, and now I'm trying to get y by itself. So here's why I wanted us to talk about those properties today. Basically, I need to get this to cancel. So here's what I want you to imagine. The way that I got a log base 3 to cancel in property format was, remember this property? If this base and this base are the same, those cancel each other and it's just equal to y. That's what I'm going to use. So this seems really strange, but whatever I do to an equation, I want to do it to both sides. Like if I multiply by 5, I multiply by both sides. If I divide, I do it by both sides. You maybe never knew this before, but I can actually also take both sides as exponents of a number. So right now, I took both sides as exponents of 3. And if you don't quite understand what I just did, let me rewrite it again. What I just did is I took what I had on both sides of the equal sign and I made them both as powers of the base 3. And the reason I chose 3 is because that's my base right here. That's the thing I'm trying to get rid of. The way this works is, see, check it out. Now I've got a 3 and a 3, so that cancels, and I have essentially just solved for y. And once you get y by itself, you're done. That's our goal. So I just found the inverse. And here's what I mean. The inverse of a log will be something exponential because they're inverses of each other. It takes a few to get the hang of it, so let's do the next one. Step 1, switch x and y. Step 2, solve for y. Now, I want to say something about this plus 1. Because at plus 1, usually you'd think, oh, maybe you're thinking in your head, subtract 1, subtract 1. We can't do that yet because that 1 is locked inside that parentheses. Because of the parentheses, we can't get rid of the 1 yet. We got to get rid of the parentheses first. Now, remember how I said a ln is really a base e? The reason I need to know what base it is because if I'm going to try to cancel this out, I'm going to make both of these that base. So essentially what I've done this time is what I had, I made as exponents of a base of e. See that? What I had previously I made as exponents of base e. Now my little shortcut is for me not to rewrite it, to just go like this, e, and then you'll know you're making them both exponents because e is now, I wrote it so it looks like the base. That's kind of a shortcut, but if that doesn't really make sense for you, it's totally fine to write it all out like this. And now the reason I did that again is because of that property we learned, that whole part cancels. So that's equal to y plus 1. That's still e to the x. So yay, I got rid of the parentheses. Now I'm at the stage where I can get rid of the plus 1. So I would subtract from both sides. So what I end up with is e to the x, subtract 1 equals y. Alright, I'm going to now go slightly faster. And if you understood those, you could skip ahead to part E because C and D are just repeats. Alright, so here I go, a little bit faster. Step 1, switch x and y. Step 2, I'm trying to get rid of my log. This time I have a base of 2/5. I'm going to take both sides as exponents of 2/5. So my final answer is 2/5 to the x power equals y for part C. For part D, step 1, switch x and y. Step 2, I'm trying to solve for y. So get rid of the ln first, and to cancel out a ln, remember it's really ln of base e. I'm going to take both sides as exponents of e. So those cancel, it's just left with y to the 10th power. I have to get rid of the 10, so I add it. E to the x plus 10 equals y. Hopefully if you got that, you fast forwarded, but follow along now again because it's going to get trickier with E. I put in a bunch more stuff here and we're still going to switch x and y as my first step. The problem is I have to figure out what order to do everything in. So here's what I got to tell you. You want to work with the part that's multiplied with your variable last. So ideally I want to get rid of this plus 4 first if I can. And when I say if I can, this time I can because it's not locked inside of a parentheses. So if it's locked inside a parentheses, that's when you can't get rid of it first. Now I have this, and notice the 2 is still outside. The 2 is not with the log yet. It's not in a parentheses or anything, so I can get rid of that as well by dividing. And so now I have x minus 4 divided by 2, and it's your choice if you want to keep it as this or if you want to split it into 2 fractions. Either way is fine. Now I'm to the stage where I just have log base 3 of y. So now I'm going to take both sides as exponents of 3, and it looks weird, but there is my final answer. And if you split up the fraction, that would look like this. Either one would be accepted for full credit. F is actually a little easier. only this time I'm going the other way. So this time I have an exponent, and I'm going to try to make a log to get rid of the exponent. And actually I haven't taught you this yet, so make sure you're tuning into F if you haven't fast forwarded already. All right, here we are. I got x equals 2 to the y plus 1. Now I'm kind of going the other way. So we're going to use a log this time, because if you have a log, use an exponent. If you have an exponent, use a log. So you do the opposite of what you see. Now I'm going to first get rid of the minus 1. And I'm at the stage now where I'm trying to get rid of that 2 basically. I want it to just be a y. So and this time I'm going to use this property right here. And I use the numbers I'm using, but if you want, I'll rewrite it quick with the variables. So there we go. That's the property I'm going to use. So what that means is this time I want to take both sides. I want to take log base 2 of both sides. Let me show you what that means. So basically I took what I had. And I made it here and here, but then I put a log base 2 of both sides. And the reason I did that is this is that property where this part cancels, and that's just equal to y. So my final answer is log base 2 of x minus 1 equals y. Let's try part G. So similar problem. Before I take a log of both sides, I want to get the exponent by itself as much as possible, or the exponential statement. So this time, actually, you know what? Don't let me forget to switch them quick. So switch my x and y. Okay, there we go. Now I'm going to solve. So again, I want to get rid of this if I can, and I can this time because it's not locked inside. But now I want to point out I can't yet get rid of the 2 because it's part of the exponent. I can't just add 2 to both sides. That doesn't work. It's part of the exponent. So the only way to get rid of it is after the fact. What I'm going to do then is I'm going to take log base 4 of both sides, and the reason I chose 4 is because this is a 4. So now let me write this out clearly so you can see what's happening. So I'm taking log base 4 of both sides. And the reason I wanted to do that is because right here, that cancels. So I'm left with y minus 2 on that side. And another thing I want to point out is that this x plus 5 is, that whole thing got logged. So at the end, when I add 2, that doesn't add with the 5, because this is a plus 2 outside of a log, which is a very different number actually. So that's a plus 2 outside of the log. It's not with the 5, because the 5 is being logged right now. Alright, one more before we move on to our part 2 video. I've got y equals log base 5 of x minus 3. Step 1, switch your x and y. Step 2, solve for y. And this time what I notice is there's nothing else with here. There's nothing else I can add or subtract because this whole thing is in parentheses, so that's locked in there. So right away this time I'm at the step where, well, I see a log, so I'm going to exponentiate both sides. So I'm taking both sides as powers of 5. So if I want to write it out nice and neatly, this step is optional. That's what it would look like. But what's happening is those guys cancel each other. And so I've got 5 to the x power equals y minus 3. Add 3, add 3. 5 to the x power plus 3 equals y. On the next page, we're going to be graphing. Yay! Thanks for tuning in, and I'll talk to you again in a little bit.